Before we could graph quadratic functions, there is one important item we need to examine and determine first, and that is what we call as the vertex of the graph. I'm going to share to you given problems here or quadratic functions, and then the first goal is to determine the vertex of the following quadratic functions. Why do we need to determine the vertex? The answer to the question is this. We need to determine the vertex because when we graph quadratic functions, that is the main point of where the direction of the parabola is changing. Okay, vertex is also called as the turning point of the graph. It is also the point where you could see the maximum and the minimum value for the values of the function. Okay. So we are going to determine the vertex first. At the same time, when we're going to graph quadratic functions, there is a need for us to determine the vertex first before we can plot our table of values. We cannot just simply choose any values for a table of values because we may not see later on the correct parabolic graph of quadratic functions. So without further ado, let's start determining the vertex of the quadratic functions. Okay, the vertex of the quadratic function again is determined as the turning point. Okay. But there is a specific formula for us to determine the vertex of the quadratic function. That is actually the formula which will use the A, B, and C coefficients. The A, B, and C coefficients are again the coefficients of the quadratic expression in standard form. In this case, we have here the function and then whatever the expression here in standard form meaning there is a term for x squared, there is a term for an x coefficient, and there is a constant simplified already, no more duplications, right? So let's determine first the a and b coefficients here. A is 1, b is not there, C is not there as well. Okay. To determine the vertex of a quadratic function, we have here the formula. Okay, the vertex is a point. The vertex is a point containing containing coordinates x and y. Because if we talk about graphing of quadratic functions, we can plot it in a rectangular coordinate system where the two-dimensional with x-axis and the y-axis. So we have here a point in that rectangular coordinate system, x and y. So x, again, or since we don't see here any value for y here is actually your expression of f of x. So the other point for vertex is actually expression x and then the f of x. Other references will write here v, meaning this is the vertex of the given function. But first, let us go to the formula. The formula for the x coordinate of the vertex is actually negative b over 2a. I'm not going to show you how it's just derived. Okay, let's just focus on determining the x coordinate. The f of x coordinate, or again, the y coordinate also has a formula. I'm going to present it a little bit later. Let me move this item here. Okay. Let's start with the x coordinate first. So we have here the value negative of 0 over 2 times 1. So the numerator is just 0 over 2. So the value for the x coordinate of the vertex is actually 0. So we are now quite sure that the vertex contains the coordinate of 0, and then we will solve for the f of x. Okay. The solving for the partner of the ordered pair for the vertex here may come into different scenarios. Number one is using this formula for a squared I mean for ac rather over minus b squared over 4a. So this is another formula for the y coordinate. So I have been using here green. Let me just use here blue for the vertex. So that's just to differentiate the colors as well. So you have 0, and then we don't know the value for y here, or f of x. So we substitute simply 4 times 1 as your a times c, which is a 0, which is c, minus 0 squared over 4 times 1. So 4 times 1 times 0 is 0 minus 0 over 4. That's actually the value for f of x, or your y is actually 0. So this is your second, your y coordinate for your vertex. Therefore, the vertex for number 1 is at 0, 0, the origin of the rectangular coordinate system. This is one scenario. As I've mentioned earlier, we have two different scenarios. Number one scenario, I have used also blue here. So anyway, I'm just going to check the colors later. The first scenario is using this formula. The second scenario may also be easier for some than the formula here, because this is actually difficult to remember or memorize for some. So for so that you will not be memorizing the formula here, looking only at the formula for the x, whatever the value of your x here, simply substitute it in the given to get your f of x. So if x is 0, 0 squared, your f of x is 0. That is why you have this vertex. Again, the first scenario is using this formula. But for those of you who will forget this formula, no worries. Simply substitute the value for x here to the given, and whatever the value for f of x, that's your point. So this is your vertex. Let us try it in number 2. Number 2, the a coefficient is 1, b coefficient is -4, c coefficient is 0. Okay? So for x coordinate, you have negative of b, which is -4. Please take note of the signs. Since b is already a negative number and you have a negative sign here, it should be negative of the b, which is -4, all over 2 times 1. So that's +4 all over 2. So x is actually 2. So your vertex is a point containing 2, comma, we don't know yet. The next is using the formula. So for f of x or y, you will have this formula: 4ac minus b squared over 4a. Substituting the values here. So you have 4 times 1 times 0 minus -4 squared all over 4 times 1. 4 times 1 times 0 is 0. So we have here -16. So exponential first. The square of -4 is +16. And you have a negative sign, so you have a -16 here. All over 4 times 1, which is 4. So the f of x, or the y value for the vertex, is actually -16 over 4, is which is -4. So this is actually what the partner of 2 is. But of course, again, this is just one scenario. If you will not, if you have not familiarized the formula, simply substitute this to the given. So you have 2 squared minus 4 times 2. 2 squared is 4 minus 8. So 4 minus 8 is -4. You have -4. Therefore, this is the correct vertex. Okay. Number 3, the vertex here could be determined if we have determined here the a, b, and c coefficients. A is 1, b is 8, and c is -5. So x is actually -b over 2a. So you have -8 over 2 times 1. So your x coordinate is -4. So your vertex is a point with -4 and then a partner later. Again, may use the second scenario automatically. So let's use second scenario: -4 squared plus 8 times -4 is -4 plus 5. So you have -4 squared is 16. 8 times -4 is minus 32. And you have plus 5. So you have here 16 minus 30 is -16 plus 5. It should be negative 11. So it should be negative 11. So this should be negative 4, negative 11. Let's recheck. This is negative 32, that's 16. Ay, sorry, this is my mistake. It was actually minus 5. So this is minus 5. So that's negative 16 minus 5, that's negative 21. Negative 16. Okay, this is not negative 11, it's negative 21. Let me rewrite this one here. So you have negative 21. But that is for the second scenario. Let's still use the first scenario here just for reference. F of x is equal to y, which is equal to 4ac minus b squared over 4a. So you have 4, your a is 1, your c is negative 5, minus 8 squared over 4 times 1. So 4 times 1 times negative 5 is negative 20. And then minus 64 all over 4. So negative, the top would be negative 84 over 4. So the value for your f of x or your y coordinate is actually negative 21. As you can see, we have the same value. So this is your vertex. Last number. Last number, you have here a is equal to 2, b is equal to negative 8, and c, which is actually 3. Let's try to use here the vertex, the formula. So you have negative of negative 8. This is 3. Sorry for not good handwriting. All over 2 times 2. That's positive 8 over 4. So your vertex is actually 2. Your y or your f of x coordinate or your y coordinate is equal to 4ac minus b squared over 4a. This is actually equal to 4. This is equal, sorry, 4 times 2 times 3 minus 8 squared all over 4 times 2. So 4 times 2 times 3, that's 8 times 3, which is 24, minus 64 all over 8. 24 minus 64 is negative 40. Divide by 8. So your f of x or your y coordinate is actually negative 5. Let's try to check. Baka kasi there's mistake in my computation. So let's try to use here the formula. So you have 2, your x is 2 squared minus x, 8 times 2 rather, plus 3. So 2 squared is 4 times 2, so you have 8, minus 16 plus 3. 8 plus 3 is 11, minus 16, negative 5. That's why they are just the same. So your vertex here is a point at 2, negative 5. So this is how we determine the vertex of the quadratic functions. Again, the purpose for this is to come up with the proper table of values for us to have or to see the correct and the not correct, the actual form of the graph. And at the same time, vertex may tell us the minimum and the maximum value of the function. In the next video, we will still also determine the vertex for the given functions, but we are going to use another method. We call it the vertex form of quadratic functions. See you. Please continue studying.